one of our Mars missions. Before we get into it, I want to welcome our presenters who are going to be participating in this briefing today. First, we have Nikki Fox. She's the Associate Administrator for the Science Mission here at NASA. On the phone, we have Katie Stack Morgan, the Perseverance Project scientist. She's going to present via phone. We also have Professor Joel Hurwitz, Perseverance scientist and lead author of the paper that was just released today. Very exciting. He's on the phone as well. And also we have Lindsay Hayes. She's the senior Mars scientist. She's with us here in person. As well as we have our new associate administrator, who, if you have any questions, you will ask questions of him as well. Amit, who I'm grateful he's accepted the post as the top lead career employee. He formerly worked at on the mission for Artemis, we're going to talk about that a little bit later. But for today's press conference, for the last 30 years, NASA has been exploring Mars. And in that exploration, we're looking for signs of life, we're looking for water, but 30 years of exploration. And in the past, we thought we found signs of life. And when we did that, we put it out to the scientific community. And the scientific community would come back and say, well listen, there's different explanations for what you think was life. It actually was created by something else. And that's been the history, the partnership that NASA has with its discoveries and the scientific community that will, in essence, pressure test what we think we've found. So we're talking about Perseverance. This was a mission sent to Mars under President Trump's first presidency. And a year ago, we found a sample, and it was, again, we're exploring in places where there were rivers and where there were lakes. And much as on Earth, we think that that's where we'd see signs of ancient life on Mars. And so a year ago, we thought we found what we believe to be signs of microbial life on the Mars surface. And so we put it out to our scientific friends to pressure test it, to analyze it, and go, did we get this right? Do we think this is signs of ancient life on Mars? And after a year of review, they've come back and they said, listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars, which is incredibly exciting. Again, we're gonna break that down for all of you with our lead scientists here at NASA, those who have been involved. Dr. Hurwitz, Professor Hurwitz wrote the paper that was released today, so we want to hear from him as well. But I would be remiss if I didn't talk about what we're actually doing here at NASA, which is human flight exploration. Many of you have heard about our Artemis program. At the first part of next year, we're going to send 4 astronauts back to the moon, but we're going to just go around the moon. We're not going to land in Artemis 2, which is coming early next year. But about a year and a half after that, we're going to do Artemis 3. We're going back to the moon. And this time, we are going to stay for a longer period of time at the start, but we want a long-term presence of life on the moon led by America. And what's important with this mission is what we learn on this mission to the moon is going to help us to actually put American boots on Mars. And it's an exciting time. And again, we have great science around it. We're pushing our partners. We're pushing NASA. We're in a second space race right now. The Chinese want to get back to the moon before us. That's not going to happen. America has led in space in the past, and we are going to continue to lead in space in the future. And again, this discovery today, I hope makes everyone excited about the future missions that we're going to have and the exploration we're going to do and the science we're going to develop to make sure we can send Americans, mankind throughout the universe. And so, but we do want to lean into this exciting news that we have today. And to give us more, I'm going to turn it over to Nikki Fox, who is the Associate Administrator for our science mission. Nikki.
Thank you so much. Thank you. Yes, it really is an exciting day today. NASA, what we do is we study the seemingly impossible. That's what we do every day at NASA Science. And NASA Science is undisputably the global authority in the search for life beyond our home planet. And so today we are going to talk to you about this amazing, exciting discovery. And I also want to make sure that we put context around it. And you see like how it fits into our search for life in the universe. Our galaxy is 100 billion light years across. And within 10 light years of Earth, there are at least 400 known planets. And that means there is a possibility, some would even say a probability, of life beyond Earth, including maybe even complex intelligent life. And today we are really showing you how we are kind of one step closer to answering humanity's one of their most profound questions, and that is, are we truly alone in the universe? So if I could have the first image, please, that would be great. So last July, as Secretary Duffy eloquently described, NASA's Perseverance rover found a leopard-spotted rock at Mars. And scientists immediately knew. It was interesting, we hadn't seen anything like that before on Mars. And we talked about it last summer. The moment we found it, we put out the images for everybody to see and everybody to share in the joy of NASA science. And, you know, today, we're really here celebrating that incredible hard work of the science team as they literally tried to prove it wasn't interesting. Maybe it's just something else. Maybe it's not, you know, the key result that we've been waiting for. And so they've done the analysis on these leopard spots, and we think they are potentially made by some sort of ancient life. This finding by our incredible Perseverance rover is the closest we've actually come to discovering ancient life on Mars. And if you can't tell, we're really excited about that. But, you know, I want to put it into context. It's a signature. It's a sort of leftover sign. It's not life itself. And it certainly could have been from ancient life, and that would have been something that was there billions of years ago, nothing that's current there. And, you know, it could certainly, as we say, be made by ancient life. And what that means is we look at everything we know about life on Earth. And this is the kind of signature that we would see that was made by something biological. In this case, it's kind of the equivalent of seeing like leftover fossils, you know, leftovers from a meal, and maybe that meal's been excreted by a microbe, and that's what we're seeing in this sample. And, you know, again, as Secretary Duffy said, we don't know for sure that's what it is, and we won't stop after this first analysis. This certainly is not the final answer. But we have this first result, and we're sharing it with you, the world, and we are asking you to look and give you our analyses also. And that's what we do in NASA science. This is, you know, how we find our information. It's part of that long journey. We ask a question, we design a mission that can actually go and address that question. We develop the technology, we build the hardware, we launch it into space. It takes the data, it brings back the information that we need here, we analyze it, and we come up with answers to those really, really tough questions. We've actually been studying Mars with, even as early as 60 years ago when we sent our first missions there to take pictures of Mars and tell us really that's quite an interesting place and we really do want to send humans there. And so we've been doing this so we can understand the planet so we are ready to send our humans there. We certainly, as we look forward, we plan to send more missions to Mars in support of the Artemis program, which we're really proud of. And it will open the door for humans to study and better understand the red planet, and perhaps even one day bring back Martian samples home for us to actually study here on Earth. And I want to underscore the point that NASA science discoveries do not just happen at random. They are the rewarding results from meticulous, long-term strategic planning. We send these missions to really address these incredible questions. And each new discovery helps us just, kind of drive what research is coming next. What missions do we want to design next so we can kind of take that full bench of tools with us to solve the problems of how best to support, to explore our solar system. First with robotic missions and then with humans. And before I pass it on to my colleagues who are going to tell you all about the details of this incredible finding, I just want to talk a little bit more about how NASA searches for life. And there's so much happening that I am incredibly excited about. We have Europa Clipper that is on its way to explore an icy moon of Jupiter to investigate whether the subsurface ocean underneath that icy crust has the potential to support life. After that, we'll launch Dragonfly, which has been deemed the most exciting science space mission of your lifetime. And it's a drone. It's the size of an SUV, and it's going to be humanity's first airborne science mission to another world. Dragonfly will explore the amazing world of Saturn's moon Titan, which is the only place in our solar system where that have lakes of liquid on the surface. And with Dragonfly, it's going to let us understand the prebiotic chemistry that predominated Earth here before the origin of life. And the other thing we're looking for all over the universe is potentially habitable worlds. 30 years ago, we first discovered an exoplanet around another star system, and today we know of thousands of them. This has changed the very way that we look at our night sky. We know that there is, on average, a planet for every star in the sky. And as I've been saying, each new mission is specifically designed based on all of the knowledge that we've gained so far. And in this case, the knowledge is allowing us to lean forward to study a concept mission that is supported in the president's budget called Habitable Worlds Observatory. And that will allow us to search for habitable worlds and for signs of life around 100 of our nearest stars. Super, super exciting. Mm-hmm. From its vantage point in deep space, it will observe a variety of critical targets for us to go and explore, for us to sort of put our fleet of telescopes staring at those, including our amazing James Webb Space Telescope, and of course our upcoming flagship mission that we launched in 2027, the Nancy Grace Roman Space Telescope. Super excited. Yay, Roman. The Habitable Worlds Observatory insights could help keep astronauts and human infrastructure safe in space, and it will be the most powerful telescope NASA has ever launched, maintaining Americans' leadership in space, which is so important. But for now, back to the present and back to Mars. And so I am delighted to turn it over to Dr. Katie Stack-Morgan to tell us more about Perseverance's work on Mars, and she's joining us by phone. Take it away, Katie.
Thank you so much, Nikki.